Okay, these are the notes for November 15th assignment in class, page 376, numbers 5 through 12, 23 through 25, 29, and 34. It's homework number 31. This is 6.3, the use of similar polygons. So remember, we've been talking about similarity now, and the important thing about similar figures is that their corresponding angles are congruent and the corresponding side lengths are proportional. It's that proportionality that allows them to remain looking the same, even though it's either been dilated, enlarged, or reduced. Now, as we talked about in congruent triangles, what's important about a similarity statement is that you list the corresponding angles in the proper order. So to say ABCD is similar to EFGH, we use this symbol here, which signifies similar. And then the corresponding angles I have, again from where it's been written, I have A to E, I have angle B to angle F, angle C to angle G, and angle D is congruent to angle H. These are the corresponding angles of these two polygons. And then the ratios of corresponding sides, again, I have AB, segment AB, over segment EF. That ratio will be equal to segment BC over segment FG, which will be equal to segment CD over GH, and segment AD over EH. So the corresponding angles are congruent. The ratios of corresponding side lengths are also the same. So the shapes are proportional. In example 1, I'm going to use the similarity statement. I'm going to list all the congruent angles. So ABC is similar to triangle DEF. So I know that angle A is congruent to angle D. Angle B is congruent to angle E. And last, angle C is congruent to angle F. Now below it asks me to check that the ratios of corresponding side lengths are equal. So I set them up. I have 25. A to B corresponds to E to D. BC corresponds to EF. And I have AC corresponds to DF. So I set those up as ratios, and I see if they're proportional. So I'll take 25 over 35.
Good morning,
25 over 35, is that equal to 20 over 28? Is that equal to 30 over 42? So then you need to reduce these to see if they're all equal. 25 over 35, 5 goes into both, and that would go in 5 to 7. 5 times 25, 7 into 35. 20 over 28, what goes into both? Well, 4 goes into both, and that again goes in 5 to 20, and 7 into the 28. And then we have 30 over 42. 6 goes into both. Again, 6 times 5 is 30. 6 times 7 is 42. So these all reduce down to 5/7, so indeed they are proportional. So these two triangles, ABC, R, and DEF, are similar. And the statement of proportionality is what we just did, reducing those down. 5/7 is equal to 5/7 is equal to 5/7. Scale factor, we briefly talked about this when we were doing dilations. Scale factor is really the multiplier. It's the common ratio of side lengths of two similar polygons. It's how they've changed. Is it 2? Is it 1/2? Did they double? Are they half as large? And that's the scale factor. How much bigger or smaller is the new shape? So in practice 1 here, triangle JKL similar to PQR, list all congruent angles. So I can tell from how it's written that angle J corresponds with angle P. Angle K corresponds with angle Q. And angle L corresponds with angle R. And the second part here, corresponding side lengths, there must have been a picture that somehow got removed. So we'll skip that and go on to the next example. Find the scale factor. Determine whether the polygons are similar. If they are, write a similarity statement and find the scale factor. So all we need to do is compare corresponding sides. So again, I have 12 is to 8. If these are similar, that would be equal to 30 over 20, would be equal to 27 over 18, would be equal to 33 over 22. So, and then we reduce these. So 12 over 8, 4 goes into both, that is 3 over 2. 30 over 20, 10 goes into each, that is also 3 over 2. 27 to 18, 9 goes into both, again 3 over 2. If you struggle with this, you can always just put them in your calculator, hit math, enter, enter, and it will change it to the reduced fraction. 33 over 22, 11 goes into each, and that is 3 over 2. Oops, sorry, it looks like a 9. And we see they're all 3 over 2. So if I'm going to write a similarity statement, I can take the corresponding angles, R, S, T, U, and then write it similar to D, E, F, G. So R, S, T, U is similar to D, E, F, G. And the scale factor here is what I've already found. It's the reduced fraction of the corresponding side lengths, is 3 over 2. Now what you have to be cautious of is how it puts it. While the sides correspond 3 to 2, the way this is phrased, RSTU 2 DEFG implies that DEFG is the new image, making this the old. So when I compare corresponding side lengths, if I compare new over old, that scale factor would have been automatically set up. Scale factor is new over old. We prefer new over the old. And really this should be 2 over 3 would be our scale factor if we started with this shape and became this shape. It would be 3 over 2 if we started here and then went larger. This is the multiplier, and if you multiply these, if this is your original times 2/3, they result in the side lengths of the smaller polygon. So 2/3 would be the appropriate scale factor for RSTU 2 DEFG. So now if I need to find the value of x, this is where our proportions come in, cross-multiplying, I need to compare corresponding side lengths. So I know that BC corresponds to HJ. This is my unknown quantity, so now I just need to find another side that has 2 values, so I can only solve for 1. So it really doesn't matter where you start. If I want to start here, then I'll say 12 is to the corresponding side of the smaller polygon 8 as my unknown quantity is to the other corresponding side, 16. So when I cross-multiply to solve, I get 8x equals 12 times 16, which is 192. And then to solve for x, I just divide both sides by 8. So I have x is equal to 24. So down below here, scale factor. Remember, the scale factor again is our new over old. So if it was QRST, if this is the old, and it became ABCD, then clearly it got larger. So I should see a scale factor greater than 1. And if I compare the corresponding sides correctly, I have 12. I'm going to compare just AB to QR over 6, which equals 2 over 1, or simply 2. So this has a scale factor of 2, which means all side lengths here have been doubled to result in a new polygon ABCD. If I needed to find the value of x, I should be able to see that it is simply 8, twice the side length of 4. But I can set up the proportion. 12 is to 6. as x is to 4. When you cross multiply and solve, I get 6x equals 48. Divide by 6 on both sides, and I'm left with x equals 8. Okay, so let's go look at how this relates to the perimeter. If two polygons are similar, then the ratio of their perimeters is equal to the ratios of their corresponding side lengths. Since the length of the sides is first dimension, just dealing with length or distance, then it would indicate that the perimeter, also a measurement of distance, responds in the same manner. If all the sides are doubled, then the perimeter is doubled. And that's what this says down below. So I can use that to also find a proportion. In example 4, we're constructing a rectangular play area. Playground is rectangular with length of 25 and width of 15. The new play area will be similar, but only 10 meters in length. So let's draw a second picture. And we know that the length here is only 10, but I don't know the width. So if I want to find the scale factor, again, scale factor is the new over the old. If you flip it, it's going to be wrong every time. So if this is my new length, to find the scale factor, I simply put 10 over 25, as these are the corresponding parts, length and length. And 10 to 25 results in 2/5. So there's your scale factor. Now if I'm going to find the perimeter, all I need to do is find the width, because I know the other length here as a rectangle is 10. And I know this is also x. So I just set up a proportion to help me find the missing width. So I know 10 is to 25, as x is to 15. So this results in 25x equals 150. When I divide both sides by 25, I'm left with x equals 6. So then if I need to find the perimeter, I know the perimeter is 10 plus 10, that's 20, and 6 and 6, which is 12, so the perimeter is 22. I could also find the perimeter using this ratio here, 25 to 15, and I know the perimeter here is 50, 60, 70. The perimeter here is 80. So I could set it up as a proportion that says the scale factor 2 to 5, the smaller rectangle is to the larger, as the perimeter of the smaller, that's my unknown, is to the perimeter of the larger, which is 80. Then when I cross multiply here, I have 5x equals 160, divide by 5, and I will again get 22. So what you have to be cautious of when you set up the proportion, just be aware that right now I have the smaller rectangle on top, larger on the bottom. It doesn't matter if I flip it, but they do need to correspond to the same shape on the top and the bottom. So in the practice problems down below, if I need to find the scale factor, again, new over old, then I just relate FGHJK. So this is my old, and this would be the new. So if I compare corresponding parts, I just need to find the side that corresponds. I have that here with A to B and F to G. Then I compare 10 to 15. And I reduce. This is 2/3. Now I can see if this is my original, it definitely got smaller, so I should see a scale factor, which is your multiplier, less than 1. That's going to result in a smaller figure. If I then need to find the value of x, I just compare corresponding parts again. I already have 1, 10 and 15. Now I can compare x and 18, and I set it up. It doesn't really matter where you start. If we want to start with the smaller one, 10 to 15, so small is to large, its corresponding part, as small is to large, the corresponding part, 18. When I cross multiply, I get 15x equals 180. I divide both sides by 15, and I'm left with the solution, the length of my side. 180 over 15 is 12. If I then need to find the perimeter of ABCD, I've got two sides, now I've got to find all the rest. Well, I know that this is my multiplier, so really what I'm doing is I'm multiplying all these side lengths by 2/3. So if I set those up in proportions, 2 is to 3, that's just the reduced. The smaller polygon is to the larger, as the smaller is to the larger. And this will find GH, which will then become BC. I cross multiply and I get 3x equals 18. Divide both sides by 3, and x is 6. So I know that that length is 6. There's 1. I can do the same thing. The smaller is to the larger, as x is to 12. I cross multiply again and I get 3x equals 24. Divide both sides by 3, and x is 8. And the final side, I know 2 is to 3, smaller is to large, as my unknown ED is to 15. Cross multiply and solve, 3x equals 30. Divide by 3, and x is 10. I can then find the perimeter simply by adding. I have 10 and 10 is 20. 12 and 8 is another 20. 40 plus 6, perimeter is equal to 46.